What's going on, guys? In this video, we're going to cover another fundamental part of organic chemistry, and that has to do with bond lines. Bond lines is really just a fast and efficient way of representing large and difficult molecules that are so synonymous with organic chemistry. So, without the knowledge of bond lines, if I asked you to represent propane, you'd probably do something like this. Drawing the symbols and all the necessary carbon bonds and carbon-hydrogen bonds, which that can be pretty monotonous for a 3-carbon compound, let alone, I don't know, a 12-carbon compound. With bond lines, this is all I have to do to represent propane. So, the steps really is numbering your large carbon chain and knowing that each point of this little structure here represents a carbon. So this point represents carbon 1, this point represents carbon 2, and so on. And the advantages are quite clear. One, it's very, very time effective. Two, you don't have to represent carbons or hydrogens by their symbol. You can just draw lines, and it's known that this carbon has 3 hydrogens, this carbon has 2 hydrogens, and so on. What you do have to identify, though, is functional groups. So if I had an F here, or fluorine on carbon 3, I would have to draw a line here and an F to denote the fluorine carbon 3 bond. And let's say I had a double bond between carbon 1 and carbon 2. I would represent that by means of another line. So these two representations are showing the same molecule. So let's jump to a more difficult example. Let's say I have this beautiful compound. I'm pretty tired of drawing all these H's already. Alright, so the first step you should do is number your carbons, so you know how many lines to draw on your bond line structure. 1, 2, 3 carbons, so we're going to draw 3 points and number them accordingly. So carbon 1, there's nothing special going on. Carbon 2 and carbon 3 are double bonded, so we're going to draw another line here in between carbon 2 and 3 to represent the double bond. And on carbon 3, we have a functional group here with bromine. So we're going to draw a line and a BR to show bromine. And that's all there is to it. Let's work one in reverse real quick just to get a better understanding of the overall process. Let's say, oh gosh, I'm not looking forward to drawing this the real way. Say we have this structure, and we want to show it with symbols and lines and that kind of fun stuff. Well, first thing you should do is number, like I said, each point, just so you know how many hydrogens you're dealing with. And it makes it easier to transfer data from this to the here and so on. So we have 5 carbons on our carbon chain, so let's draw 5 carbons. On carbon 2, we have an iodine, so we'll draw the iodine. In between carbon 3 and 4, in between 3 and 4 we have a triple bond. We'll draw a triple bond there. And now all there is to do is fill out the remaining hydrogens. Oh my god, I don't want to do that. So as I said before, these two structures are representing the same molecule. This one is more time effective, while this one is a more, I don't know, descriptive representation. Let's go into one more example. Let's say we are given this structure. Let's get this bond line out of here. We already know what the video is about. And this time, I'm going to represent carbon-hydrogen bonds just with lines because I'm sick and tired of drawing all the hydrogens. Alright, so on this example, finding the longest carbon chain is a little different because you have a divergence here. But if you do a carbon count, 1, 2, 3, 4, 5, 1, 2, 3, 4, this path is clearly the longest carbon chain, so we'll number it like here. So we're going to have 5 points on our bond line structure. One, 2, 3, 4, 5. And in between carbon 3 and 4, we have a double bond, so we know what to do there. On 4, we also have a hydroxyl group, so for any non-carbon hydrogen bond, we have to represent with this symbol. So we'll draw our OH. And on carbon 3, we have a methyl group. Well, since it's still a carbon, all we have to do is draw the line to represent a new point for our new carbon. And these two are the same thing. And that's really all there is to bond lines. Again, the advantages are pretty clear. It reduces clutter, for one, and it puts the focus on the functional groups, which are most of the time the most important groups when determining factors like boiling point, freezing point, stuff like that. So that's it for this video. We'll see you next time.